Okay, let's continue on our lecture regarding object-oriented programming. And so we left off on Monday, kind of saying like this, we defined how we create classes. So far, our classes that we've been created was just using the keyword class and then the name, and they've been empty definitions. So far all we've put in our creation of the class is the doc string, but basically there's no actual definition to the class. We've been kind of adding attributes to the class in this ad hoc manner. So we would do something like create a time class object, but right now our time class object doesn't really have much of a definition, but we've been adding attributes like the hour and the minute and the seconds. And then, and we've created these functions that right now what they do is they take two time objects and then they add them together. So, and kind of our most recent version of our function that adds two times together is what it will do is we have these helper functions. One function will convert the time object, the hours, minutes, and seconds, into the total number of seconds after midnight, and then adds the total number of seconds together. And then once you have the total number of seconds, it kind of divides by 60, and things like that to kind of get the total number of hours, minutes, and seconds. Okay, and so that's where we've left off. And what we want to do now is we want to start defining methods. Okay, so methods are functions, but they are functions that are included as part of the class definition. They are functions that are associated with the particular class. So they're basically, just think of them as functions. Okay, methods are just functions, except the key difference is that the definition of the function happens inside the definition of the class. Okay, so if you define a function at kind of the top level global environment, the double under main, that's just a regular old function. If you define the function inside the class definition, then it becomes a method. Okay, and then the syntax for kind of invoking the method is just ever so slightly different from calling a function. So here we are going to just kind of start off with our blank time class definition. And again, right now there's nothing happening inside when we define this class. We're not defining any attributes. We're not defining any methods right now. Okay, and then right now we just have this function that takes the time class object and it prints it out as like in this format of hours, minutes, and seconds. So this is how the functions as we have it written, and then we can say let's define an instance of the time class object. We're going to call it start. We just give it some attributes on the fly, and we say start.hour is 9, start.minute is 45, start.seconds is 0, and then we say print this out, and this is how it prints it out. Okay? So the only thing to turn this print time into a method, okay, all I have to do is I just define my time class object, and basically I just copy the function definition and I'm going to put it inside the time class definition. And now this is a method, okay? Now this is a method. So here I've got class time, okay? I've basically just copied and pasted the exact function definition and I just put it inside the class definition, okay? Now this is a method, okay? So if I want to use this method, I have to create a new instance of the time class object. So one thing is that you can change the definition of the time class, but that doesn't retroactively change like past definitions of those time class objects, right? It's kind of like every year Honda releases the new model of the Honda Civic, okay? They just make slight updates. But it's not like suddenly your old Honda Civic that you bought 2 years ago suddenly gets refreshed and updated, okay? You have to kind of if you want the latest version, you have to go out and buy it, okay? So it's not like your phone updates where it just gets pushed to you and then they update automatically, okay? You have to take the new definition and you have to create a new instance of it using this new definition, okay? So we're gonna do, so I'm gonna define and create another object called start using the new definition of the time class. And then again, right now our class definition doesn't have any methods, doesn't have any attributes. It just has one method associated with it. And so that's what we have. And then to invoke the method, okay, I can this is the less common way to call a method. You can call it by its full name by saying from the time class, call the .printtime function or method defined within the time class, and that works, okay? Here, you can also do, remember, start is an instance of the time class, and this is the more common way to invoke a method, is you take that instance of that object, in our case, the start object, and you'll do .printtime, and it invokes the method on itself. Okay, so this is going to be probably the most frequent way that you're going to see it, and this is how it's going to work. But again, you can you can invoke the method the less common way by using its full name, saying time class .printtime. But what do you want to print? You want to print it for the start instance of the time class object. But again, kind of the more common way is once you have an instance of this object, you can just call the method name. Yes, question?
What's the difference between this and what we did earlier, which was print time and then parentheses start?
Print time start?
Yeah.
So this print time is defined in the global environment, and this is just a function that's just sitting around in the global environment. And if you try to call print time on something that wasn't a time class object, it'll error out, right?
Yeah, I get it.
Okay. And whereas this thing, if you do start.printtime here, this method can't be, well, you can invoke it here, and you can pass here an object that's not a time class object, and it will error out. But in general, if you say, well, the only way I'm going to invoke the methods is by kind of using the object class name or the instance of this object, and then call the method, then it will be invoked correctly. Okay. Now, when you call a method from the object itself, like we have here, again, start is just an instance of the time class object. The start object is known as the subject of the method. Okay, and it's going to get passed in as the first argument. So normally, when you call print time, you have to pass some kind of argument to it, and if you don't pass an argument to it, the function would error out. Okay, but here I didn't pass an argument to it, and that's because when you invoke a method from within an object, it's going to pass the object itself as the argument. Okay, and so that's why it knew. Okay, well, we have it was able to run. Okay, so in this example above, the start object gets passed into the kind of the method print time here. So by convention, the first argument of a method is going to be called self, because generally when you invoke a method, you're going to be passing the object itself as the first argument. That's what happens. And so the convention is you're gonna write self as the argument name. So here when we define the method up here, I just called time because I was just kind of copying and pasting the text here. But the general kind of convention when you define a method would be to use the name self here. So here I'm going to refine my time definition for the class time object, and I have the method print time, and we're going to use the argument self here. And so again, whenever you invoke a method, the object itself will get passed in as the argument for self, or really the first argument. And what this will do is it'll take self-hour, self.minute, self.second, and put that into, print that out here, okay? And then I'm gonna have another method here that will take time self and convert it into the number of seconds after minute using time to int. So we're gonna do self.hour times 60 plus self.minute, and then take the number of minutes times 60 and add the number of seconds, and that will return the total number of seconds. Okay, so I can do start is a new instance of the time class object using our new definition. Start.hour, start.minute, start.second is going to be 9:45. And then so I can say print the time, we get 9:45, and I can now invoke the method time to int, and it will say how many seconds after midnight is 9 hours and 45 minutes, and we get 35,100 seconds. Okay. And so here I can take this function. I can create a function that will say, all right, let's take some integers and turn those back into a time. So here we're going to create, a function, integer to time, and we'll take create a new kind of time object. We'll take the number of seconds, do a div mod, and that will give us minutes and seconds. And then if our minutes is over 60, we'll do a div mod again, and that will give us the number of hours and minutes, and that will return a time. Okay, so this, now notice this here, this function is not going to be a method of the time object, because this thing, the argument that it takes in is the number of seconds, right? And so we are not going to invoke it as the time object, because the time object uses itself as kind of the first thing. And here, what we want to do is we want to return a time object, and it's a function where the argument is the number of seconds. So there's no kind of object that we would invoke this on. So this function is not going to be a method here. You had a question, yes?
So previously, before you introduced the self, like the self argument, why would print time, like start.print time, still work without the self argument?
Because what it does is whatever I could name whatever I want. It doesn't have to be self. It could just here. It could be called time. It could be foot. It could be whatever you want. When you invoke, when you invoke the method, it passes itself as the first argument, no matter what it's named. So the convention is to name that first argument self, but it's not required. Okay, just like the convention is to do, import pandas as PD, but you're not required to do that. Okay, so the convention is to call it self, and that just kind of makes it easier for everybody to kind of understand what you're doing. But again, you can use whatever name you want, and whatever thing is the first argument it's going to pass itself as the first argument. So that's just how all of how Python handles object-oriented stuff with the methods. So does that answer your question? Okay. All right. So let's go ahead and try adding a few more methods here. So we're going to just keep expanding our definition of the time class object. So here I have print time, time to integer, and then I'm going to add a method called increment. And what increment will do is it's going to require an argument, right? So it always passes itself as the first argument. So we're going to put self in as the first argument, but this will require an additional argument called the number of seconds, how many seconds we want to increment by. And so so what we will do is we will take take our current value of self, we're going to convert it to an integer, and that will be some number of seconds. And then we're going to add that to the number of seconds in increments. So let's say we want to increment it by 60 seconds. We are going to do 60 seconds plus, the time after we've converted to integers, added that to the 60 seconds. Now we have a total number of, some other number of seconds. And then what we're going to return is we're going to call the function integer to time, which is not defined as part of a method, but just defined in the kind of global environment here. We're going to take the number of seconds, convert it to a time, and that's what it's going to return here. All right. So here, start is going to be 9:45. I can do start.printtime 9:45. I could say let's increment it by 60 seconds, okay? And we'll get 9:46. I could say let's increment it by 1200 seconds, okay? And that will take us 20 minutes, all right? Later, or some other number there, okay? 1337 will take us to 10:07 and 17 seconds. Now, when you do something like start.increment, remember the .increment takes two arguments, the first being itself and the second being the number of seconds. And so whenever I write start.increment 1337, the self always gets passed in as the first argument. And that happens like when it sees this 1332nd, this 30, that goes into seconds, okay? If I do something like start.increment 1337 and 460, I get an error, okay? It says you're supposed to give me only two arguments, self and the number of seconds, and it says you gave me 3. Even though I only wrote 2, and that's because the self, the object itself, always gets kind of passed in as the first argument here. So this is not going to work. Yeah, question?
So in this case, with the increment method, would that be a modifier function?
Well, this is not modifying. So if we ask what is start.hour, it's still 9. Okay, so this function as of now is not a modifier. This method does not modify it because the start object, like after I've incremented it, is still like the start hour is still 9. Okay, if what we can do is we can change the method definition so that when I increment it, it does change this attribute like start.hour. Like if I started off at 9:45 and I say increment it by 1200 seconds, okay? If I increment 9:45 by 1200 seconds, it returns 10:05, and I can change my method definition to say I want it to now start.hour now to reflect this new time, 10, rather than 9. Okay, and in that case, it would be a modifier. But right now, as it's defined, it's not a modifier because even after I do the increment, start.hour remains unchanged at 9. So as of the definition that we have it right now, it's not a modifier.
So how could you make it a modifier?
Yeah, well, I'll show you that.
Oh,
okay. So you can have it like, I think I have it here, but anyway, so you can have it just kind of modify the things within the function definition here. Okay, so let me just keep adding more methods, and I hope this is okay. As our time definition, the class time object is getting more and more complicated, but hopefully it's simple enough. Okay, so we have a print time we have a time to integer, we have an increment method, and now we're going to do, we're going to add a method called isAfter, okay? And isAfter is a comparison. And what it wants to do is it wants to compare itself versus another time class object. So we want to ask, hey, is 9:45, is it after 10:45? The answer to that will be false. Is 9:45 after 7:30? The answer to that will be true, okay? And so we're gonna, the way we're gonna call isAfter, right, is going to be, we have the current and we have the kind of the other time, and we want to do a comparison. And so in this case, because we're going to compare it to another thing, it's going to take into an account another object. So this method will have two arguments, the self, which is always the case. We always have self as the first argument. And then the second argument is going to be another time class object. So we're going to call this thing, by convention, we're going to call it other. So if you're going to kind of compare one object to another object, the convention is to call the other object the other, okay? And what we're going to do is we're just going to do self, and so what we'll do is we'll convert 9:45 into a number of seconds after midnight, and then we'll convert the other time, 10:45, to a number of seconds after midnight, and then we can just say, hey, which number of seconds is bigger? And that's a simple answer. It's going to be, true or false. Greater than or less than, true or false. And it will return the answer to this question. So we'll do the other, convert the other time to an integer. We'll take our current time, convert it to an integer, and we'll just return that. So here, we're going to call start. Start will be 9:45. I'm going to do start.increment, and I'm going to add 1,337 seconds to it. And I'm going to save start.increment to end, okay? And so end is going to be 10:07:17. And I'm going to ask end.isAfter start. So we're going to convert 10:07 into number of seconds after midnight. Is that number greater than 9:45? And the answer there is going to be true. End is after the start. Is start after the end? Start is after end? That is false when we convert it to the number of seconds after midnight. That number is smaller than the number of 9:45 is fewer seconds after midnight than 10:07, and so we get a false there. Okay, so right now we've just defined a time class, and we have a whole bunch of methods as part of our definition. Right now we've still been kind of having to define the number of hours, the number of minutes, the number of seconds, these attributes as part of, we have to kind of do this manually here, all right? And so there's a very important method, and it's called the init method, the initialize. This is going to, every time we create a time class object, it's going to initialize. Let me give you your first view quiz answer. Question 1 is C, okay? Question 1 is C. So I wrote, it's been annoying that every time I redefine the start object, I also have to assign the hours, minutes, and second attributes, okay? And so there's a special method called init, double under init, okay? Where you have, these are called dunder methods because it's double underscore. Double underscore, you have two underscores, init, two underscores, and so we call these the double underscore or the dunder methods, okay? And these are kind of like special, they define like a special set of methods that can be used in a lot of kind of object-oriented stuff. So dunder init is going to be invoked anytime you create a new time class object here, okay? So here, inside my definition for class time, I'm going to add one more method here. And this method is going to be the dunder init method, dunder initialize. Again, self is always the first argument. And then it will accept three arguments, hour, minutes, and seconds. The default values will be 0 for all three of these things. And we're going to take those hours and we're going to use them to define the attributes of the object that gets defined. And so here I'm going to say self.hour is going to be hours, self.minute, and self.seconds. Okay, so remember the self is the argument that gets passed in, the object itself gets passed in, and we're going to define these attributes, hours, minutes, and seconds, using the arguments of class time. Yeah, question?
Just to make sure, if it's double under, that means in the normal class you do not need to initialize the functions like in it, and it will still be able to call it.
I'm sorry?
So since in it is, you said underscore in it, underscore is double under function.
Yeah.
Which, does that mean that it doesn't have to be initialized in the normal class, or do you still need to initialize it?
So we the prior definitions of our time class didn't have this double under init, and so when I create new objects here, like it just creates the new object, but that new object has no attributes. Right? And if I want to have attributes like the hour and the minute and the seconds, I had to kind of do those after the fact, right? And I did.
I understand.
Yeah.
My question is, do you need to initialize it in order to call the init function, or can you like do that, call it without?
So here I'm going to redefine my time class definition. Like, what does it mean for it to be a time class object? And then when I say, when I just invoke a new instance of the time class object, it automatically runs the initialize. So once you have this double under init, it gets invoked every single time you create a new instance of the time class object. So you don't have to manually do it, but it, like, by defining double under init, it's going to get invoked every single time. And so here I'm going to just create a new instance of the time class object, and when I do that, it will invoke by itself the double under init, and it's going to define hours, minutes, and seconds. And so now midnight, we will have midnight.hour. Like if I say, what is midnight.hour, it's going to be 0. It's now defined. Okay. Whereas like over here, if I say, if I use the old definition and I say, let's make an instance of this, okay? And if I say midnight.hour, midnight.hour has not been defined, okay? Using the old definition, okay? But now that I've defined the double under init, when I invoke it, as soon as I invoke it, midnight.hour gets defined because it's assigned right here during the initialize function or initialize method. Yeah. Is that what you're asking?
Yeah.
Yeah. Okay. So so here I can say, hey, all right, let's make a new time. So I didn't pass any arguments. We had default values of 0, 0, 0. Here I could say time 9, and this is going to put 9 into the first kind of argument for hour. Okay, the first argument other than itself. And if I do 9, 45, then it's going to put 9 for the hour, 45 for the seconds, right? So my new time is going to be 9:45. Okay, so far I've always been using, we've called this method print time, okay? And what we do is we print out the time, where we take the number of hours, put it into 2 characters, number of minutes, put it into 2 characters, number of seconds, put it into 2 characters, and separate them by colons, okay? There is another method, and this is the Dunder string method, okay? The Dunder string method is a special method that basically returns the string representation of an object. And so when you call print on an object in Python, what Python will do is it's going to basically ask the object, do you have a string representation? Okay, so kind of like when you say print none, okay, this is the string representation of none. Okay, whereas none itself is actually like the object itself returns nothing. Okay, but the string representation of none is the string NONE. Okay, and so similarly, rather than calling print time, all I'm going to do is I'm going to just change the definition. Like inside the method, I'm going to change the name from print time into dunder string, okay? The dunder string method. And now when I call print on a time class object, it's going to invoke the dunder string method, and it will return that, okay? So the only difference here is that I've changed the name of this method from print time to dunder string, and then rather than actually printing the string, okay, because the print function in Python doesn't return anything, we're going to say return the string, okay? Return the string where you put in 09:45:00. Return that string, okay? This is the dunder string method. So now with this definition, I'm going to create a new time, 9:45, and I no longer have time.print time, but I can call print on new underscore time, and I get 9:45. Okay, that's different from the object itself. The object itself is a time class object defined at this located at this memory location. But when you call print on the new underscore time, it will give you the string representation, which is going to be 09:45:00. So I would say these are probably two of your most important double underscore methods. Two of the most important dunder methods is the init. So in general, probably every single class definition that you create, you'll want to have an init method in there to kind of define like what are the attributes that are part of this class definition. And then the dunder string method is going to kind of like how should this be represented when you print it out, right? When you print out the object, how should it be represented, right? So is that okay? Instead of having this slightly clunky print time method, I mean, which made sense. It made sense. But kind of the preferred method is to use the dunder string, and then you would call print on the object, and it will return this. All right, let's go ahead and give you your second. Wait, how do I do this? Second answer, Q2 is B. Okay, Q2 is B. All right, so this I think is so cool in Python. Is we have methods that allow us to do what we call operator overloading. Okay, so we have more of these dunder methods, and the operator overloading dunder methods get invoked when you use operators like plus and times and things like that. So when you have a list, or like when you have strings, we can do plus this string plus this string, and it basically concatenates them together. And when you have a list, you can take this list plus this list, and it kind of concatenates them together and gives you a longer list, right? That's not like normal behavior when you think about like what does addition do. But those are basically overloaded operators is what we call them, okay? So in addition to everything else, I can I can add the dunder add method, okay? So the dunder add method is going to get invoked whenever you use the plus sign, okay? And so when you use the plus sign, the one on the left is going to be the self. The thing that comes after the plus will be the other, right? So if you do like 5 plus 7, the 5 is the self, the 7 is the other. And so when we're going to define a method basically, which is the dunder add self other, and basically we're saying we want to take these two objects and add them together. So we're going to say self other, and we're going to assume that our self is a time object, the other is a time object, and we want to add these two time objects together. So let's say the self is 9:45, the other is an hour and 5 minutes or something, we want to be able to add these two together. So how can we do that? Well, we have the time to int. We have the time to int method. So we will invoke that on itself to get the number of seconds after midnight. We'll invoke the time to int on the other object. Okay, assuming the other object is also a time class object, we can invoke the time to int method on that thing. We'll add those two together to get the total number of seconds. And now that we have the total number of seconds, we'll call the function defined in the global environment integer to time, and we're going to return that thing. Okay, so here I'm going to do start 9:45. Duration is also going to be a time object. So I mean, I could do print start. Print start will be 9:45. Print duration, which will be 1:35. And I could do, if I do start plus duration, I'm going to get back a time class object, which is not helpful. But I can print out whatever that result is. I can say print start plus duration. Print start plus duration is going to be 9:45 plus an hour 35, which will result in 11:20. Okay, and so this gets invoked just by using the kind of the plus operator. Whereas kind of older definitions, that we don't, it doesn't know how to handle the plus operator. So if I tried to do something similar, with the older definition, and it did start plus duration. Okay, it says unsupported operand, right? It says I don't know how to do a plus between two of these things. Okay, but by defining the dunder add method inside our time class definition, we can now use the plus operator. Okay, we might want to, so right now our plus operator assumes the other in the add is going to be a time class object. But what if we wanted something simple where we say, hey, you know what? Here we have a time class object and I just want to add 60 seconds to it, or I want to add 1,000 seconds. Okay, can we have the option to add integers? All right, and the answer is yes. The answer is yes. Okay, we can further define. We can kind of expand our definition of the dunder add method to check to see if the other object is an integer, or I should really, is to check to see if the other object is a time class object. Okay, so if the other object is a time class object, then we're going to add the time. And if the other object is not a time class object, then we're just going to increment it by the number of seconds. So here we're going to kind of split the definition, and we're going to say basically if you have, so we're going to ask if is instance is going to check to see if an object belongs to, is it an instance of a certain class? So is the other object an instance of the time class object? If it is, we will call the add time method. Add time will convert self to int, time to int, and it will invoke time to int on the other and add those two things together. If it's not, then we're just going to call self.increment. Self.increment just takes the number of seconds and adds it to itself. So we basically have like two different kind of use cases for the dunder add method. So we're just kind of expanding our time class definition here. So I'm going to initialize, I'm going to create 9:45, and I can say, all right, what happens when you do 9:45 plus an hour and 35? We get 11:20. What happens if I take 9:45 and add 1,337 seconds? Okay, that takes you to 10:07:17. Okay, so now we can use this plus operator for like different kinds of things, not just time objects, but also integers, right? So I think this is kind of neat in that, like, as you think of like defining classes and doing things with them, what kind of things do you want to do? And you might want to be able to add other, like 2 time objects together. You might want to add time plus integers and things like that. Okay? Now, this, if I try to do 1337 plus start, okay, we run into an error. Okay? If I say, hey, I want you to take 1,337 seconds and add that to the start time, now Python complains and says, you know what, I don't know how to do this. You're asking me to do a plus, and basically it's looking for some kind of operator between integer and time. Okay, and so here, if we want this, we can do we can have the right hand side add. Okay, and so this will kind of do a check to see. You know, if it can't figure out the plus between 1337 and start, it's going to say, well, maybe I can do a right-hand side on start and 1337. So with the right-hand side, basically, I can do right-hand side add between self and other, and that's just going to be self, add, and the other. Okay, so on the right-hand side is going to be the self, and then the left-hand side is the other. So normally, it's the thing before the plus is the self, and the thing after the plus is the other. When you do radd, so double under radd is just the kind of opposite, and so this could get invoked. And so this will allow us to kind of do, you know, swap the order of the operands. Okay, so we're making our time class definition longer and longer, but we're just adding this kind of one little line that just says, hey, you know what, let's allow for right-hand side addition, where we're going to do self and other, and we're just going to do self and invoke the double under method for the add. Okay, so now I can do 945 duration, I can do start plus duration, I can do start plus 1337, and now I can also do 1337 plus start, and that works. That works there as well. Okay, here, this, so this is, I think, a really neat feature. Once we've defined double under add, okay, now anytime there's addition involved, Python understands, okay? So we never defined, like, how do you do sum, okay? But because we have a double under add method, we can create a list of times. So I'm going to do 120, 140, 130. I can put those 3 things into a list of T1, T2, and T3, and I can just call sum on this thing, and it works, okay? Simply because I've used the dunder add. Okay, because I've defined dunder add here, Python now understands addition for this object class, and now we can call sum and things like that, which I think is like so cool. All right, and so we're going to be looking at more stuff with like class definitions. There's like other really cool things that you can do that Python can do with all of these things. Okay. Now, you can add attributes to an object at any time, which is kind of what we were doing at the beginning. It's better practice not to do that, okay? And so sometimes as you're just working, you want to kind of see like what are the variables inside a thing, like what are the attributes inside some kind of class object, and we can just call vars on that for now, okay? And that will tell you what are the different attributes there. Okay, that's it for today. Let me go ahead and give you your last view quiz answer. Last answer is A. Okay, but yeah, we'll keep looking at some object-oriented stuff in Python. Just some really cool stuff. you want some fun, look up the double underscore methods, dunder methods in Python, and there's a lot of kind of cool things. And so we'll look at like container dunder methods for like all the things that lists and things to do. We'll take a look at that next time. All right, have a great rest of your day, and we'll see you on Friday.